Often, our go-to is a circle when we learn fractions, but modeling with more than just a circle is ideal for learning fractions, so students can interact with fractions using many different mediums. So let's begin with working with the fraction 3/4. I'm going to use some cube trains. You see along the top, I have 1, 2, 3, 4, 5, 6 cube trains. Note then, why would I use 8 cube trains to represent 4? Well, using some reasoning, if I were to split into fourths, I have 3 copies of 1/4, which means that we can represent 3/4 using cube trains or any other medium in many different ways. More than just 3/4, so we're building equivalent fractions even though students don't realize that's exactly what they're doing. Let's work with the GeoBoard. I have a 5x5 GeoBoard, and this was taken directly from the GeoBoard in our interactive manipulatives, and I put a band around the outside. Notice that I now have 4 rows and 4 columns. So if I were to grab 3 of those rows with the yellow binder, I now have 3/4 of my GeoBoard circled or squared in a yellow square. So if I partition into 4 equal parts, now you could do this horizontally or we could do it vertically, we would get the same. So I have 3 copies of 1/4 colored in yellow. Let's work with the fraction 3/4 using counters. So I have 3 bears to represent the numerator, and I have 4 bears to represent the denominator. Again, partitioning into 3 copies of 1/4. I see that they're split. So this is very similar to the snap cubes. I just used the straight 3/4 instead of 6/8, but we could have 6 yellow bears and 8 red bears if we wanted to do that as well. We can also use a number line. Notice I don't have anything labeled. I'm going to label 0 and 1, and notice that my number line extends past 1 because we know that fractions can lie anywhere on a number line. I have 3 copies of 1/4, so I need to partition into 4 pieces with 1/4, 2/4, and 3/4. I can see that 3/4 is labeled right there. So as students become more familiar with fractions, again we want to make sure we extend our number line to the left of 0 and more whole numbers included than 1 to show that the fractions can lie anywhere on the number line, not just between 0 and 1. For your homework, I want you to model 2/3 using the following models. Cube trains, a GeoBoard that uses an area of 4 pegs by 4 pegs. We did 5x5, so you just need to break it down just a smaller 4x4. Counters of your choice. Show 3 different ways to create 2/3 using counters, as well as a number line. Then answer the following. Which of the modeling activities was easiest? Which was hardest? And explain your reasoning. Scan and upload your documents to the model discussion board. Take a moment to view your classmates' responses as perhaps they saw things a little more differently than you. Partitioning versus iterating. These are some common words that you may have heard me say, particularly partitioning. Means that we reduce the size of the fractional parts but preserve the whole. Iterating preserves the size of the fractional parts but increases the whole. So I have the fraction 3/2, which we know is 3 copies of 1/2. Notice that a circle and a half is our unit. So I need to partition our unit in half first, and I need 3 copies of 1/2. So each part is 1/2. I'm going to iterate by taking 3 copies of 1/2. I noticed that I can then take some of my circles and piece them together. I can take these two halves to make a whole circle. I have a fourth and a fourth that I could put together with this half to make another whole with a remaining of a fourth of a circle left. So it would look something like this. Our unit is changing into these 12 triangles. I want to find the fraction 2/3 using this particular unit. Knowing that our unit can change and knowing that our unit is very particular, it's not always one, it could be many different things. So we need to partition first. I'm going to partition into thirds because we need 2 copies of 1/3. So I break my 12 into groups of 3, and now I need 2 of those groups, so I'm iterating. Modeling using a variety of different shapes and sizes is also key to show us the parts do not need to be equal to represent fractional pieces. The parts do not need to be clearly lined. The parts do not have to be the same shape, and the shaded region does not need to be grouped into one part. Jamie and Melissa made a hexagon sandwich with pattern blocks, 1 trapezoid and 3 triangles as pictured in the top right. They discussed the fraction of the hexagon modeled by 1 triangle. Jamie says it's 1/4 because the hexagon is divided into 4 pieces. Melissa says it's 1/6 because it would take 6 triangles to cover the hexagon. Both Jamie and Melissa had arguments to justify their answers. Can you comment on their thinking? Which reasoning is closest to your own thinking about this question? Is Jamie correct? Is Melissa correct? Take a moment, pause the video, and think through this a little bit. In my opinion, I would say that Melissa would be the correct one, as I seriously would need 3 more triangles in order to fill up our hexagon. So 1 triangle is 1/6 of the hexagon. Although there are 4 pieces, not all the pieces are the same size. It's important that, again, that our unit is the same. A half of a hexagon and 3 triangles are not the same size or unit. We can use Cuisenaire rods as fractions as well. So notice that there are 10 different ones, each one ranging. The colors are pretty standard. You can change them up a bit, but these are the pretty standard Cuisenaire rods that are used. And it's a way to introduce fractions as well as work with fractions, adding fractions. It also can be used when you're trying to find the least common multiple or greatest common factor, as we'll do in other grades. There is a template that you can print out and color yourself and have your own set of Cuisenaire rods on our site under the manipulatives. So take a peek at that. Perhaps you want to cut some of yours out or use the manipulative virtual manipulatives that we have, which we're going to do here in one moment. So I just grabbed the virtual manipulative of the Cuisenaire rods. The link will be in our manipulatives folder. Our first question is, if the dark green rod is the unit, what fraction does the red rod represent? So I pulled out the dark green rod and I see that 3 red rods can be placed on the bottom to make it equivalent. But I'm only interested in 1 red rod. So 1 red rod is equivalent this represents 2 over 1, 2, 3, 4, 5, 6. It also could mean 1 over 1, 2, 3, because it takes 3 red ones to make a whole green one. If we keep the dark green rod as our unit, what fraction does the lime green rod represent? So I'm going to toss away I'm going to pull out the lime green. I see that the lime green represents 3/6. Or 1, 2, 3 copies, 4, 5, 6, or 3 copies of 1/6. If the blue rod is our unit rod, what fraction does the dark green rod represent? So the blue rod is now our unit rod, and the dark green is here. Okay. Blue is 1, 2, 3, 4, 5, 6, 7, 8, 9. And our top is 1, 2, 3, 4, 5, 6. So 6/9, or 6 copies, 1, 2, 3, 4, 5, 6, 6 copies of 1/9. If the blue rod is the unit, what does the orange rod represent? Notice that the orange rod is longer than the blue rod, but we do know that the blue rod represents 1/9. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 copies of 1/9, or 10/9. If the brown rod is the unit, what does the red rod represent? Or does the red rod represent 1/4? So we need the blue rod. Oops, I'm sorry, we need the brown rod. Is the red rod 1/4? So if I were to cut into 4 pieces, oops, I apologize, I don't know what I did. I think I zoomed in. So we'll put, because if it is, there would be 4 copies of 1/4 would give us a whole. And certainly 4 copies of 1/4 gives us the whole unit of the brown rod. So yes, it represents 1/4. If the orange rod is the unit, put the orange rod out. If the orange rod is the unit, 5 copies of another rod placed end to end represents 3 1/2. Which rod is it? Take a stab and see what you come up with. Did you guess the black rod? If I lined up 5 black rods, I should get 3, oops, and half of an orange rod. Homework is to play around with these Cuisenaire rods. Place the red and orange rod end to end. This is your unit rod. Write 2 questions using this new unit. The first question, the fraction must be less than 1, and the second question, the fraction must be greater than 1. Post your 2 questions to the Cuisenaire rods discussion board. Respond to a classmate's question. Return back to your questions and reply to any comments that are listed on your discussion post.